Hey, all, I'm doing this strictly for review purposes today. So if it gets a little long because I'm talking a little bit too much, like I can do, you can feel free to fast forward or rewind or just go to the pieces of doing a hypothesis test that you find most difficult or tricky or need a little review help on. So we started hypothesis test talking about means. And there are 5 steps in a hypothesis test. The first of which was to establish that we've met the appropriate conditions to do a hypothesis test. And so we always have to, actually, let me write this down. We always have to ensure that we have a random sample. And of course, we're not just going to write the word random. We are going to say, what is random? So here we have a sample of doctors. And there are 30 of them. So I would say something like the 30 doctors were randomly sampled. The reason we want to sample randomly is so that we can try to eliminate any bias in our sample. We also need to have independence amongst our individual samples. So our 30 doctors, and we're talking about their ages, our 30 doctors, we need to make sure that they were independent of each other so that ages did not influence each other's ages, which seems to make sense. So the doctors' ages are independent. So one doctor being older is not affecting another doctor's age. Their ages are independent of each other. And then when we're doing a hypothesis test for means, we need to make sure our sample size is large enough. The reason we do that is so that we can make some calculations using a normal model. The rule here is that we need our sample to be greater or equal to 30. So n, our sample size, need to be greater than or equal to 30. And so I would do something like this. Well, our sample size is 30, which is greater than or equal to 30. So I'm just saying like, hey, our sample size is 30, which meets the criteria of being greater than or equal to 30 because it's equal to. And so I put a little check mark there saying we have a large enough sample size. So once we have met these conditions to do a hypothesis test, the next step would be to write hypotheses. So we believe, or we have information, that the average age of doctors is 46, and we have a standard deviation for that, 4.2 years. And so in our sample, we get an average age of 48.6. And so this person in this hospital, specific hospital system, thinks that the average age in their system is actually older. So what we will assume to be true until we can find some evidence otherwise, we will assume, which we call the null hypothesis, that our mean, represented by Greek letter mu, will assume it's equal to what they say it is, which is 46 years old. This person in this hospital believes an alternative to be true. Alternative. This is for review, so I broke that word up. So this person thinks that the average, again, average mu is older, greater than what they're saying it is, 46. These are our hypotheses. The null hypothesis is what we are going to believe or assume is true until we make some calculations and we get some information. So until we get the appropriate statistical information to say, like, hey, that's not true. Actually, the age is older. So let's see what happens here. We're going to make some calculations. Um, we have a normal model. That's why I made sure we had a big enough sample size. The average that we think is true is 46. That's our null hypothesis. Comes from our hypotheses. That goes right in the middle. We have a sample average of 48.6, so that's somewhere over here. Sample average, that's X bar. And we have the greater than symbol, which means we should be shading in the right tail. If I had a less than symbol, we would be shading in the left tail. If I had a not equals to symbol over here, we would be shading in both, which means whatever number we calculated, we would multiply by 2. So whenever we have a not equals to, we multiply by 2 because we need the area in both tails. So this tells us which way to shade. It's pointing to the right, we shade the right. If it's pointing to the left, we shade the left. And if it's a not equals to, we shade both of them and we multiply our answer from Desmos by 2. So in Desmos, we would say we have a normal distribution. We would type that in there just like that. We have an average of 46. That's what we believe is true until we can figure out it's not. And then we have to tell it our standard error. We take the standard deviation that we're given and divide by the square root of our sample size. So we're told our standard deviation is 4.2. Our sample size is 30, so we'll square root 30. We are trying to find this area. So my minimum is what's on the left of that area. Well, it's 48.6. My maximum is what's on the right of this area. Well, this thing goes on forever to infinity, and so we'd leave it as infinity. I'm going to skip the part where I type that in there. If you need help with that, please ask. But when we get that, we get this number, 0.0003. And this is a review, but I'm sort of talking sometimes about it like, you've never heard it before, just in case you forget. This is what we call p-value. This is the probability that we get a sample mean of 48.6 if the real mean is 46. So if I get an average of these doctors' ages, it's not always going to be the same thing. Sometimes it's going to be larger, sometimes it's going to be smaller. But this p-value tells us that we have a less than 1% chance of getting this sample mean if 46 is the actual average age of the doctors in this system. So it's not really likely that our sample mean happens if this is really the average age. So we have a decision to make. That's our step 4. I'll say we have a choice to make. We compare our p-value to this alpha value that we're given in the problem of 0.05. And our p-value is 0.0003. If the p-value is smaller than the alpha value, which again comes from the problem up here, and you're always going to be given what alpha is. If the p-value is smaller, then we will reject the null hypothesis and say that the average age is not 46. If the p-value is larger, we will fail to reject the null hypothesis. We don't have enough evidence to show that it's different or greater, so we will just keep assuming it's 46. So here, the p-value is smaller. So I might write small because the p-value is smaller. So if the p-value is small, we will reject the null hypothesis, which we call H sub 0. So that means we have really good evidence here, especially because our p-value is really small. We have good evidence here to show that the average age of the doctors at this hospital is greater than 46 years old, because it would be almost impossible to get 48.6 as the average age from my 30 doctors if the average age really was 46. So we're rejecting the null hypothesis, and we are saying that, and this is what we would write at the end. We're always going to state what is our p-value, and we're going to state what alpha value we compared it to. If you don't totally understand what this alpha value is, just know that you have to compare it to P, and that's how you decide if you reject the null or you fail to reject it. If we're rejecting the null, we're going to say there is evidence. We have evidence. There is enough evidence. And we can write this the same way every time. If we fail to reject the null, we're going to say there is not enough evidence. We don't have enough evidence to kick the null out. So there is enough evidence to show here that the average age of doctors in this system, and I'm going to skip the in this system, is greater than 46. And you would write that out in words. I just have a lack of space. And we can write this explanation the same way every time. State the p-value and alpha value. State whether there is or is not enough evidence. So there is enough evidence if we reject. There is not enough evidence if we fail to reject. And then we want to say, well, evidence of what? The average age of doctors being greater than 46. So we do have that evidence. Again, I kind of rushed through this whole process, which we took several days to do together in class. So if there's still a little bit of confusion, do make sure that you find me before test time and ask for some help on these. Make sure you do the practice. Make sure you check your answers if you can. You can always stop by my room and grab the answers. And good luck if you are retaking or taking this test the first time around.